Got it. Okay. Here we are at module number 5, week number 3 of 16. If I'm not mistaken, there's like 22 modules to get through. Yep, there are 22. So we're working our way. Don't worry about getting behind. We'll have plenty of time to catch up. As usual, I'm going to go through 2 modules. Feel free to ask any questions along the way. We're going to have a number of Cisco commands to talk about, and then a couple of pictures. Not too bad, not too shabby, not too shabby. So starting with the privilege levels in iOS. Cisco iOS provides different level access. By default, you have the 2 levels, the user exec, which is privilege 1, and privilege exec mode, which is level 15. In total, counting from 0, you have 16 levels, and you can assign a custom privilege level with the privilege mode and then the level command in global config. For a privilege exec level, it would look something like this. There are normally 2 methods for assigning passwords to different privilege levels. If you want a specific user, you would add the username to it. Duh. If you want a privilege level to a specific exact mode, then you would enable secret level. So the privilege level stuff does have some limitations. For example, there's no access control to specific interfaces, ports, logical interfaces, or slots on a router. The commands available at lower privilege levels are always executable at the higher. Commands specifically set at a higher privilege level are not available for lower. That's how access control works. Assigning a command with multiple keywords allows access to all the commands that use those keywords. So anything like show IP route would allow the user to show and show IP commands. For role-based, everything from 12.3 provides finer granular access control through the command line. Network admins can create different views of router configurations for different users. This enables network admins to be able to give a unique look to every user and not just give them everything. So you have things like the root view to configure any view of the system. So admins have to be root. There's the CLI that lets you see a specific set of commands, and super view, which consists of 1 or more CLI views. The super view has several characteristics. You can share them with multiple super views. Commands can't be configured for a super view. An admin must add commands to the CLI view and then add them to the super view. The users who are logged in as super view can access all commands that are configured for them. Each one has a password and is used to switch between different super views or from a CLI view to a super view. Deleting a super view does not delete the associated CLI view since it's kind of modular. The views are all unique to each other. You're just connecting them together into a super view. Here are the steps to do it. You enable the AAA new model in global config. You'll create a parser view. This enables that view configuration mode. You'll assign a password, of course, assign any commands that go to it, and then exit. If you want more of a breakdown of the commands and description, here it is. Got the commands, the parser mode, what you want to include, anything that's exclusive, anything that's excluded, all what interface and what command. To make a super view, it's just the same as configuring a regular view, except that the name command is used to assign commands to the super view. So this is the way to make that super view. You did it the first time to make the various command line views. Now the super view is made by the collection of those views. I think of it as hierarchical. To verify, use enable view. And then enter the name of the view to verify and provide the password to log in and see. You can use a question mark to verify that the commands available are the correct ones. So you see when the question mark, here's a list of those that they can run. Here is a super view for a role support. Here's for a junior admin. A couple different commands on what they can and can't do. This is awesome. For example, for new admins who you're onboarding, you don't want to give them the keys to the kingdom, but they do need to do some work. So you give them only what they need. It's just another way of also implementing the least privilege principle. Give the worker only what they need and nothing more. That's exactly this. Give them what they need and nothing more to do their work. Any questions before moving on to module number 6? Yeah. Well, concepts of access control lists have been covered in Security Plus thoroughly. So it's just how do you take things like access control lists into things like Cisco iOS? Yeah, it is a bunch of commands, but this is how you implement ACL. Right then. Switching gears into module number 6. The Cisco iOS resilient configuration feature allows for faster recovery if somebody maliciously or unintentionally reformats Flash or erases the startup config file in NVRAM. Got to have a backup plan. The config file is a primary boot set, the copy of the running configuration that was in the router. The feature secures the smallest working set of files to preserve persistent storage space. It doesn't require extra space. The feature automatically detects image or config version mismatch. It only local storage is used, and it can be disabled through a console session. To do this, you do the secure boot image in global config. When enabled for the first time, whatever is the running config and image is secured, and the log entry is generated. So a great way to back yourself up should somebody accidentally delete things or maliciously try to change things around, you can use this to bring up your configuration again and not be totally knocked out of the internet. Restoring a image from a secure archive looks like this. You would need to reload and break the booting sequence to enter into ROM mode. There you would show the directory, and it would list the contents that are there, including the secure bootset file. You would boot the router with the secure bootset image. In this case, it's a flash 0. You would enter the global config mode and restore the secure configuration to a file name of whatever you want. Like in this case, they're restoring it to the rescue CFG, and then restoring that to running config in order to copy the file out. And now they'll run with the original or the whatever configuration was there prior to the screw up. You could also do SCP just like you would to send a file to a Linux box. You could also do it for iOS. Since it is a secure method, it is totally possible. You do have to enable SSH. If you're doing local authentication, then that user has to have at least privilege level 15. You would have to set a new model and define who can access it, and then enable the SCP. And then should this issue happen of losing your configuration, you could bring it back. So in case, for whatever reason, the local storage on the router gets corrupted, you have another copy and you can upload. If you do not know the steps to get to break the sequence and get into that ROM mode, this is how you do it. You gotta do that confreg with the hex. And then you would be able to copy the file back and get your system back up. If someone gains physical access to a router, they could obviously gain control of that device through the password recovery procedure. You can mitigate that by having the no service password recovery set. There are no other arguments or keywords. It's just when it's enabled, then you can't reset. If you have to bring a system back who has that enabled, you would break the sequence. You would be prompted to do the break action. You would then be able to reboot with the factory default settings and then continue. Oh yeah. Cisco is notorious for having a bunch of RCEs or hard-coded passwords in their iOS. Pretty crazy. Some default services that Cisco has that are usually in the sight of attackers are things like the Cisco Discovery Protocol, the Link Layer Discovery Protocol. That one is an open standard and it's enabled in Cisco devices. They are meant to discover and troubleshoot other devices on the network, but as usual, they were insecure. So they kind of cause a problem. Here are the services that are enabled by default in iOS. Obviously, an attacker will choose any service or protocol that would make the device easy to get into and would obviously hit the ones that are enabled by default. So as usual, don't just put a router on a network and just think it's all said and done. Always go through its configuration, always dig further. Don't just put it out of the box and assume it's all said and done. Here's more services that are enabled or disabled by default. Here are some Cisco recommendations for some of those services in the list. So like LLVP should be disabled globally. FTP should be disabled. TFTP should be disabled. Of course, adjust this to your needs. Don't just take this as gospel and do it everywhere. See what you need on your network and then enable disable as appropriate to ensure the minimal amount of services are available, the minimal amount of protocols necessary to work are available, and everything else is locked down. AutoSecure can lock down the management plane functions and the forwarding plane services and functions of a router. You have several management plane services like bootp, because Cisco is still catching up, CDP, FTP, TFTP, PAD, UDP, TCP, among a bunch of others. With AutoSecure, you can add a legal notification, otherwise known as a banner. You can secure password and login functions. You can secure things like NTP, SSH. There are 3 forwarding plane services and functions that AutoSecure enables. Things like the Cisco Express forwarding, the traffic filtering with access control lists, and firewall inspection for all the common protocols. The AutoSecure command enables this feature. You can do it interactive or non-interactive. This is showing the AutoSecure command and things that you would need. When you type in AutoSecure, you're going to get a wizard that'll guide you through the configuration. So you type AutoSecure, you'll get a welcome message. It'll get information about the interfaces. It'll start disabling unnecessary services. It'll prompt you for a banner and passwords and tell you that, hey, everything is secured as far as it knows. AutoSecure should be used when a router is initially being configured. They recommend not on production routers because it's automatic and you should really be doing it yourself for a production system. Dynamic routing performs several activities like network discovery and maintaining routing tables. Its important advantages of dynamic routing, the ability to be able to select the best path without human interference, the ability to automatically discover a new best path. It allows routers to automatically learn about networks from other routers. Routing systems, of course, can be attacked by disrupting those peer network routers by falsifying or spoofing the information carried within the routing protocols. It can be used to misinform, cause denial of service, cause traffic to flow in a path that it shouldn't. So while routing protocols are awesome, they tend to be insecure and cause those situations to arise. We can enable things like MD5 authentication with a command, with this third command, for example. The area authentication message digest router configuration command is another one that is used. This method forces authentication on all OSPF devices. If a device is not configured with a message digest key, it won't be able to form any adjacencies with other neighbors. This is enabled on a per interface basis. And if you're like me going, I don't know about using MD5, you can also do it for SHA. You would specify the authentication keychain in global config mode by giving it a name, assigning a number, specifying the SHA authentication. You should specify when the keys will expire and then assign that key to the interface you want. Here's an example of two routers using SHA-256. In this way, they will authenticate to each other. And if somebody tries to spoof, somebody tries to falsify, it's not going to work, which is what you want. From a reporting standpoint, most network devices send log data that can be invaluable when troubleshooting any network problems or security threats. You can view this in real time, on demand, or in scheduled reports. When logging and managing information, the information flow between management hosts and the devices can either be in band, flowing across an enterprise production network, the internet, or both, or out of band, using a dedicated management network in where no production traffic resides. So you got in band, where you have the production network and that data is flowing through it, or out of band, where it just uses a different way. As a best practice, the out of band is preferred. But being realistic, it's not always possible. You don't always have another switch or enough ports on a switch or a smart switch to divide out the this management access from everything else. But it is a good idea. If you can do it, do it. Have the management information flow a different way than everything else. In-band management, again, you kind of are stuck in a smaller network. It is cost effective. It does mean that you should secure as much as possible. For example, using SSH instead of Telnet. Deciding when management channels should be open and when they should be closed. In that vein are things like Syslog. Ooh, I did not take the text out of this. But Syslog is one of the most standardized way of getting logs from any device, whether it's a networking device, a workstation, a server, a container, whatever, into one central location. It is a very standard way. You want to secure that traffic. All right, Cisco devices have a debug command that you could use to see, hey, is it connecting properly? Is it sending information? Here are different message formats that show up from Cisco devices. So you would see in a syslog things like if something's at emergency level, it's going to be a level 0, which means the system is unusable, all the way down to just informational and debugging. These are the things that would show up in syslog. The syslog facilities help you categorize system state. So you can have the format of the syslog message be a certain way. This is good later if you need to grep through your syslog. Funny enough, the syslog timestamps don't exist. You have to enable them, which to me is kind of dumb. Why isn't it enabled by default? You want to know at what time, what day a certain entry showed up at syslog. Hey, don't look at me, I didn't make iOS. But this I would highly suggest doing as part of your configuration. Enable the timestamp so you know when what happened. Great for backtracking, great for forensics, great for incident response. Because just seeing, oh, it changed. Okay, when, where? This is much more useful. Again, your syslog server can be really anything, but you want to secure that device because it's going to get the logs of everybody. So it's going to have quite the amount of information, but also secure the clients so that they don't just send syslog information unencrypted. You want that all to be secure because that's a lot of very useful information for an attacker. And whether it's out of band or in band, you want to ensure that all that information is secured from point to point. Here are the steps to setting up syslog as a client so that it would forward those logs over to a host who then would save them up. And then you could do things like enter them into a Splunk or into Graylog for further analysis. Or if you are a master of grep, you would grep through the log. That's what this would look like once all enabled. NTP, the network time protocol. Well, if you're setting up logs to keep track of time, you want to make sure that the time is right. So you could set it yourself and hope that you're accurate, or use one of the many NTP servers that exist on the internet in order to get the proper time. There are NTP networks are a hierarchy. Each system is called a stratum. The stratum is defined as the number of hop counts from the authoritative source. So 3 gets it from 2, 2 gets it from 1, 1 gets it from the actual clock itself. Very simply, you could use a couple of commands to set up these Cisco devices to talk to a NTP server, which would be these. If your organization is working on 2 or more time zones, I would suggest using UTC because it doesn't change. It doesn't change regardless of the season, doesn't change for daylight savings time. It is always the same time all year round. It is a great reference point. It makes life easy when you don't have to do any time conversion from different log files to piece together when something happened. So if you want to make life easy for yourself, for all your servers and networking devices, I would recommend using UTC. And just know that midnight UTC is 4 o'clock Pacific. SNMP is a layer 7 protocol that uses managers and agents. You have the manager, the agent, and the management information base, or MIB. You have to define the relationship between manager and agent. All managers are part of the network management system, and they run the management software. Whoever is the manager sends these GET requests to gather information. Set requests come back from those agents. And surprise, surprise, that all of this is unencrypted by default. The management information database is organized hierarchically. Everything, all the variables are defined as object IDs or OIDs. They're all organized based on RFC standards into a tree like this. This shows the MIB structure defined by Cisco. The OID can be described in words or numbers to help locate a particular variable in the tree. So the OIDs belonging to Cisco are the .ISO, the org, DoD, Internet Private Enterprise Cisco. Therefore, an OID for Cisco is 1.3.6.1.4.1.9. There are 3 versions of SNMP. You already know what I'm about to say next. Is use the latest one because that one has encryption and the other 2 are outdated anyway. All 3 do use managers, agents, and MIBs, and iOS supports all 3. Of course it does, backwards compatibility. In any network topology, there has to be at least one manager node to run the software. Network devices that can be managed, like switches, routers, servers, workstations, all have that agent. Of course, it is going to be vulnerable to attack because it's a great treasure trove of information. For SNMP version number 3, you have the message integrity and authentication. You have encryption and access control. It only takes a couple commands to implement. So if you have a Cisco device, why haven't you implemented it? If you haven't, you really should. You define the SNMP view. You define the version number, right there, version number 3. You require authentication and encryption with the priv. You give an associated view and give it only read access by adding read to it. You can use MD5, you can use SHA for authentication type. I will always suggest that you use the highest level for best security. Here is an example of configuring SNMP3 and then seeing the result of SNMP enabled. Because again, you don't want to be giving out such valuable information unencrypted on your network. There are many tools that you can use as an SNMP manager. This is a free one, Manage Engines mid browser. Once a user is configured, the tool can test to see that if it can in fact talk to that agent. In this example, it can, and it can get things like the addressing table. So it used SNMP to get the message out and say, hey, can you send me your IP address table? And it did. Everything's working as it should. And the way to confirm that it did work as confirmed is run Wireshark. And just because this worked doesn't mean it is encrypted. Always double check, always triple check. Run Wireshark nearby and see that things are actually being encrypted. This is good. Questions? Hey, the good thing is iOS does let you do help within, and Google is your friend. I wouldn't freak out so much about all the commands and trying to memorize them all, because in the real world, you use Google. Yeah, knowing about the concepts like ACLs and applying them, being able to set up SNMP, at least knowing what that it's not going to be a long trek to do. Those are simple things you can add to your running config script. So when you do have a new router to configure, it's just all part of it. Yes, YouTube is super helpful. In those two modules, I believe there's 2 labs each, 2 packet tracer labs each to work on. Along with more quizzes. I should have mentioned at the beginning, don't feel bad that you're falling behind. at the rate we're going, we're going to have a couple extra weeks where we can review. So you'll have time to catch up without adding more work. Just go at your pace. Again, every week I'm doing 2 modules. And there's 22 of them, and we just finished 6. So we're on a pretty good track. If there are no other questions, I'm going to stop the stream just so that we don't record dead space or dead air. And I'll